Hey, so you're ready to really level up your AI game? Good! Today, we are moving way beyond just typing in basic prompts. We're going to dive into some standard practices for text generation. Think of this as us building your personal AI toolkit so you can get more reliable, more sophisticated results every single time.
Does this look familiar? I bet it does. We've all been there, right? You ask the AI for something and you get back this wall of text that's formatted all weird, or it includes a bunch of stuff you didn't ask for. It's just a mess. It's frustrating. But what if I told you there's a way to command the AI to give you exactly what you need in the exact format you need it every time? Well, that's what we're here to do. All right, let's open up that toolkit. First, we're going to master getting structured, predictable output. Next up, we'll tackle how to handle enormous documents without the AI breaking a sweat. Then we'll uncover a really clever trick for controlling the AI's reasoning. And finally, we're going to peek into the future a little bit and see how AIs can actually write prompts for other AIs. Ready? Let's get into it. Okay, first tool in our belt, structured output. We've got to teach our AI to speak the language of other computer programs. Think about it. If your AI's response is just a blob of text, how is another application supposed to use it? Structured output is the key. It's the translator that makes sure the AI's answers can be easily understood and used by your apps, which saves you a ton of time and prevents a world of errors. When it comes to structure, you've got two fantastic options. First, there's JSON. It's pretty much the universal language for APIs, perfect when your code needs to reliably read what the AI is saying. Then there's YAML. Now, YAML is so much easier for us humans to actually read, and this is a big one, it supports comments. The syntax is also a bit cleaner, which means you're going to run into fewer frustrating punctuation errors. But what if you need more than just a list of data? What if you want to generate something, visual, like a flowchart to map out a process? You might think you need some fancy design tool for that, but you don't. All you need is the right command. And check this out. Look how simple and clear this prompt is. We're just asking for a flowchart using something called Mermaid syntax, which is basically just a way to describe diagrams using text. We tell it what to do, we specify the start, the end, all in plain English. It's really that easy. And boom, this is what the AI spits back out. See, it's not a picture itself, but it's the code to create one. This is the Mermaid script that perfectly describes the flowchart we asked for. Each line is a step, and those little arrows show how they all connect. Pretty neat, huh? And here is the final payoff. You take that code from the last slide, you pop it into any program that understands Mermaid, and voila, you get this clean, perfect flowchart. All from one simple text command. Now that is the power of structured output.
So, we've nailed structured output. But what happens when our input is the problem? Like when it's way too big? An AI's memory, its context window, is kind of like a small notepad. You can't just shove an entire novel onto it and expect it to remember everything, right? That's where our next tool comes in.
The solution here is a technique called chunking. And honestly, it's exactly what it sounds like. We're just breaking down that huge document into smaller bite-sized pieces or chunks that the AI can actually manage one by one.
Now, one of the smartest ways to do this is with what's called a sliding window. Imagine you're reading a giant scroll, but you're looking at it through a tiny little window. You read what's in the frame, then you slide it over just a little bit, so the new view slightly overlaps with what you just saw. That overlap? That's the secret sauce. It's how we make sure the AI keeps the context as it moves from one chunk to the next.
Now, how much you slide that window over, what we call the step size, is absolutely crucial. As you can see here, a small step size means you get a ton of overlap between your chunks. This is amazing for preserving context and making sure the AI doesn't lose the plot. The only downside, it can be a bit slower because you're processing more chunks.
And here's the other side of that coin. With a larger step size, the window jumps forward much farther. You have less overlap, which means the whole process is way faster. But you also run a higher risk of losing important connections between those chunks. So you have to decide what's more important for your project, raw speed or pinpoint accuracy. Okay, so we're managing the input, we're controlling the output, but what about the messy thinking process in the middle? Sometimes you just want the answer, You don't need to see all the work it took to get there. So how do we separate the how from the what? Let's check it out.
So picture this. You're building a tutoring app. A student asks a math problem, and the AI gives this as a response. It shows all its work, which is kind of cool, but it also gives away the final answer right away.
This doesn't just make the output messy, it completely defeats the purpose of the exercise. We need to fix this. This is where a super clever trick comes in, called the inner monologue tactic. You tell the AI, hey, I want you to think through the problem step by step, but put all of that reasoning inside a special container, like between some triple quotes. That way, your application knows exactly where that messy thinking part is and can just hide it from the end user.
And this is what the user gets to see, just the final, clean answer. Simple as that. All that step-by-step reasoning, it's still there, captured in the background where you, the developer, can see it for debugging, but it's not cluttering up the user's screen. It is genuinely the best of both worlds.
All right, for our final and most advanced tool, we are about to dive into the deep end. This is where things get really wild. We're going to talk about using one AI to write the instructions for another AI. This is called meta-prompting. Meta-prompting is exactly what it sounds like. It's prompts, about prompts. Think of it like this. You have a primary AI, let's say GPT-4, and it's acting as the project manager. It doesn't just do one task. It actually creates a whole set of instructions, new prompts, for other, more specialized AIs, like an image generator or a video creator, who then go and create the actual assets.
This flowchart really breaks it down for us. Let's say you want to create a children's book. Your initial command is super simple. Write a children's book. From that one little instruction, the AI kicks off 2 workflows at the same time. This is where the magic happens.
So here's how it plays out. You give that high-level command, GPT-4 gets to work writing the actual story. But, and here's the genius part, at the exact same time it's reading its own story and creating a series of detailed image prompts for each page. Then it sends those prompts over to an image model like Midjourney, which creates all the beautiful illustrations. And just like that, the AI has orchestrated the creation of a complete illustrated book.
And there you have it, 4 incredibly powerful techniques for your AI toolkit. You can now command structured output for predictable results. You can handle massive documents using text chunking. You can clean up AI responses with the inner monologue tactic. And you can automate entire creative projects with meta-prompting. This is what separates a casual user from a real pro. So what are you waiting for? It's time to start building.
And all of this leaves us with a fascinating, kind of mind-bending question to chew on. As these systems get better and better at directing each other, when an AI writes a prompt for another AI, who's the real author? Is it the human who gave that first simple command, or is it the AI that orchestrated the entire creative process? Something to think about.